Right, let's do another 1 minute GMAT challenge. Can you solve this question in 60 seconds, roughly? Give it a try. If you can't, then this video is most likely for you. Right, we're going to go over the basics of percentages, how to manipulate them, and more importantly, we'll see some tricks that are specific to the exam that you probably didn't learn at school, which are very important for sense checking your results and eliminating answers. So let's jump right in. So what's a percentage? Well, it's a little bit like in a fraction, we were expressing a share of something. Well, a percentage is essentially a fraction out of 100. And in fact, if I'm not mistaken, percent comes from Latin, and it essentially means out of 100%. So you can think about 25% as 25 of 100 slices of a cake. Yes, I agree, it's a very, very finely cut cake. But as we saw in fractions, we can also represent that same value by splitting the same cake into 4 parts or 4 slices and taking one of them. Right? If you look at these two diagrams, we're shading the same portion of this whole. And all these values, 25%, 25 out of 100, 1/4, they are all equal to the same thing, and they are equal to 0.25. Now, here we have to be a little bit careful because we are talking about portions of 1. Whereas in the GMAT and in real life, you often have portions of something that's bigger than 1, right? In fact, it's very common. So for example, 25% of the population of the United States of America would not be 0.25, okay? But it would be 0.25 times that population. One thing that it is very important to understand, though, is that that portion can sometimes be larger than the whole. So you can have, just like in fractions where you can have fractions bigger than 1, you can have percentages that are larger than 100%. So, for example, 150% is 150 portions of a cake that has 100 portions. So effectively, we're being very greedy here, and we're taking not just the whole cake, but we're taking half a cake extra. Okay, so 150% is equivalent to 1.5 whole cakes in this case. Now, the percentage can be treated a little bit like a unit in maths. As in, if I remove this percentage, I'm going to change the meaning of this number. So if I just delete this and say 150, you can see that's not the same as 1.5. So you have to be very careful about percentages when you use them, when you get rid of them, etc. A percentage essentially is per 100. So it represents this denominator of 100. Okay, so what happens when the percentage that we're calculating is a percentage of something that's not 1? So at GMAT Panda, what we call that thing that we're splitting is the base of the percentage. And percentages tend to be very sneaky in the GMAT for many reasons. One big mistake that people make is that they get confused between the share, the base, and the percentage share. Now, let's see a little video to explain that in a bit more detail. So, let's say that we're splitting a group of 240 people. So that's what we call the base. It's the whole rectangle in this case. And we want to take 70% of that group. That 70% is the percentage share. And how many people does that represent is going to be 240 times 0.7. So the 0.7 represents the 70%. Remember that 70% is like 70 out of 100, so 70 divided by 100, which is 0.7. 240 is the base, and so the answer is going to be 168. So that is the share, so that's the actual number of people that we end up with once we've taken 70% of the base. So another way of thinking about this is the base is the whole thing, what you're splitting. The share as a percentage is something that's always relative to the base, whereas the share is a number that is true, like even if you don't have the context of what the base is. Okay, so 168 people means something out of context. Okay, 70% of the group, well, we don't know how big the group is. It doesn't actually mean that much, right? Because it could be 70% of the whole country, or 70% of the city, or 70% of your neighborhood. And all these three things mean completely different things. Now, part of the challenge in percentage questions in the GMAT is identifying what you have and what you don't have. So it's very important when you have a percentage calculation to make that you identify what is the base, what is the percentage share, and what is the share. And you identify which of those ones you have and which is the one that you need to calculate. So for example, in this case, we have the share and we have the base, and we need to calculate the percentage share. So the base is 300. So in this case, it's a group of 300 people. And we're selecting 90 of those people. And we want to work out what percentage share that represents. The way to do that, while using this formula, is to divide 90 by 300. And we get from that 0.3, which is the same as 30%. Mathematically, the two equations we've seen are equivalent. The key is to identify which two elements do we have. Do we have the base and the percentage share, and we need to calculate the share? Or do we have the share and the base, and we need to calculate the percentage share? Now, in some occasions in the GMAT, you have to work out the base, and they give you the percentage share and the share. Those cases are rarer, and people tend to make fewer mistakes on them, in my experience. However, when you're working out what is what, be very careful to not just rely on the units. Why? Because it's not because something has a percentage at the end that it's automatically a percentage share. That could also be the share or the base. Yes, I know, it's starting to become a bit complicated. So let's say that we're surveying some part of the population. Maybe it's for a local election, and we understand that out of the 100% of respondents, 40% of them rank, let's say, economy as the number one criteria among their concerns. So 40% of the surveys think the economy is the most important part of the election. And then what we are told is that 75% of that 40% are intending on voting for candidate X. Now, in this case, the 40% is, so it's a percentage share of the initial rectangle, but then it becomes the base of the second percentage calculation. And notice that in this case, that 40%, it may look like it's a percentage share because it's got a percentage at the end. But what we would do here is we would calculate 75% of 40%. So in this case, we would have the percentage share, which is in a percentage, and the base that is also in a percentage, and we would get the share, which would be, in this case, 30%. All right? So in this case, all three have a percentage at the end, so you can't just rely on the unit to identify what is what. Percentages are one of the most dangerous problems in the GMAT. It is so common for people to make mistakes, either by adding a few zeros they shouldn't have added, or by forgetting some zeros, or by getting confused between the percentage share and the share. So what I strongly recommend is to double check all percentage calculations if you have the time. Now, how do we double check them? Well, there's two key words here. So one is to use an alternative calculation. So you want to avoid doing the same calculation a second time, because if you've made a mistake in the first time, then there's a good chance you'll make the same mistake again. And the other key word is approximate. So it's not about redoing the same detail of calculation, because otherwise you're essentially doubling the time it takes to do the question, or that part of the question. So you want to take shortcuts, and the idea is that to be able to get a quick sense check of, okay, does this feel right? Is this roughly the order of magnitude or the rough size of what I'm expecting? So let's see an example. So let's say that we're calculating 15% of 200. Now, the answer here is 30. Okay, you can check with a calculator or doing some maths on your own if you want. But it's quite common for people to do that calculation and to get 3 or 300, for example. Now, how could we sense check that quickly? Well, one way of doing it, and there's always multiple ways of doing it, is to think, okay, well, 15% is a little bit less than 20%. And 20%, some of you may know, or may know by the time they take the GMAT, that 20% is 1/5 of something. And calculating 1/5 of 200 is quite easy. That is 40. So when we get 30, it's a bit lower than 40. That feels roughly right. If we get 300 in our initial calculation, 300 is much bigger than 40. There's something not quite right there. And it would be the same thing if we had found 3 in our first calculation, because 3 is much smaller than 40, and we would expect something to be a little bit smaller, but not too small. Let's see another example. So let's say that we're calculating 48% of 250. Now, the result of that is 120. I'm not going to go into the detail of like what's the best way of calculating that. That's for another section. But one way of sense checking that is to round up the 48% to 50%. And 50% is half of something. Half of 250 is 125. Do we get something that's close to 125? Yes, 120 is just below 125. That feels right. Now, let's go back to that example of taking a 15% of something. In this case, we're taking 15% of 200. Let's say that in our calculation, we get 3,000. Now, another way of sense checking that is to think, well, what is 100% of 200? 100% of something is just itself, so it's 200. And here we're getting something that's much bigger than 200. So that would correspond to a percentage that's much bigger than 100% and therefore much bigger than 15%. So again, something doesn't quite feel right here. And in particular, what's happened is that in the calculation, we've forgotten to divide by 100 that percent bit, so the division by 100, which a lot of people tend to forget when they do this calculation. Here we can easily spot it by just doing this quick sense check. In GMAT percentages, it's very important to distinguish between a percentage of something, which is a share of something, and a percentage increase or decrease of something. And the latter represents by how much something is going to change relative to its original amount. So let's explore that in a bit more detail with an example. So let's say that we're increasing a price by 25%. Now, we can express that as, well, first of all, calculating 25% of the previous price or the old price. But since this is an increase compared to this old price, we need to then add that to the old price to get the new price. And actually, you may notice here that this 25% of the old price, so we can write that as 0.25 times the old price. But since we then have to add this to the old price, we can then factorize that together and write this as 1.25 times the old price. So when we're expressing a 25% increase, there's two ways of translating that into maths. One would be by calculating 25% of the old price and then adding it to the old price. Another way would be to directly calculate 1.25 times the old price. So this 1 point something effectively translates the fact that we're adding to the initial or old price. Let's see how that translates into a simple example. So if x is 100 and we're going to increase it by 30% and we want to work out the new value, well, there's two ways of doing that. So first of all, we can calculate 30% of 100. That gives us 30. And then we can calculate the new value by adding that 30 to the old value, and we get 130. Or we could use that shortcut that we just seen, and we could just say, well, it's going to be 1.3 times the old value, which is 130. Now, what happens if something decreases by 40%? What's going to happen then? Well, again, we're going to calculate 40% of the old value, but this time we're not going to add it to the old value, but we're going to subtract it. Right? And that makes sense because if something is decreasing, then we're going to be lower than the old value, and therefore we need to subtract something from it. And just like there is a shortcut for adding, there is also a shortcut for subtracting. So when something decreases by 40%, you can write that as minus 0.4 times the old value. But then when we factorize, that together, 1 minus 0.4 becomes 0.6. And this is another way of expressing a 40% decrease. We multiply the old value by 0.6. Another way of thinking about that is a 40% decrease of something represents just taking 60% of the original amount. Sometimes in the GMAT, you need to calculate multiple percentage increases and decreases in a row. And here, the common mistake people tend to make is that they think that they can just add and subtract these different percentage changes. So, for example, a lot of people, when they think about a question like this, so if something increases by 50% and then decreases by 50%, often people think that that is just going to go back to its original amount, right? Whereas actually, in reality, it's not the case. So let's think about this in steps. So we first apply the 50% increase. So what that means is that we're going to do 1.5 times the original amount. Now, afterwards, we want to decrease that by 50%. So what do we do? Well, we take that new amount, which is 1.5 times the original amount, and we multiply that by 0.5. Remember, 50% decrease is like doing 1 minus 0.5, so that's the same as 0.5. But if we calculate this 0.5 times 1.5, we're going to get 0.75. So actually, we're not going to go back to the original amount, but we're going to go back to 0.75 of the original amount, or 75% of the original amount. And so that is actually translating to overall a 25% decrease. Why is that the case? Well, it's because since we apply the 50% decrease afterwards, we first increase the size of the pie, and therefore when we're going to take 50% of that, there's more pie to take of it. And therefore when we're subtracting something, it's going to be more than what we added in the first instance. So overall, we're going to end up with less than what we started with. Now, let's see another example with a specific number this time. And in this case, we're going to be increasing twice that number. So let's say we start with 100 and we want to increase it by 10% and then by 20%. So first we multiply it by 1.1. That's the 10% increase, and we get 110. Then we take that new number and we increase it by 20%, so we multiply that by 1.2. And if you do the math, you will get 132 from that. And 132 is actually 32% more than the initial amount. So here again, we've increased by 10% and then by 20%. The equivalent of that is not 10 plus 20% increase. So it's not a 30% increase, but it's actually a bit more than that. Why? Because we've increased in the first step the pie, and therefore when we take 10% of that, it's more than 10% of the original amount. Right, let's jump back to the initial question and see how to solve that. So we know that we have a three-piece suit that costs $2,000, and we know that the jacket can be sold separately for 40% of the total suit price. So the first thing we're going to do is calculate what the price of that jacket is before we do the markdowns. Okay, so a markdown is a discount or a sale on an item. So The jacket we can calculate by simply doing 40% of the total price, which is 2,000. Right? So remember that of can be replaced a little bit like a times. Right? So in this case, 40% would be 0.40. Of is this times here, and the T is the total suit price. So what we need to do is to do 0.40 times 2,000. Okay, we could have written this 0.40 as 40 over 100. That's another way of writing percentages. But 0.40 is usually a bit quicker if you're comfortable writing it that way. And here, what we're just applying is the simple rule of the share is equal to the base times the percentage share. Right? So the base cost is the 3-piece suit. We're taking a percentage share of 40% and we're getting the share of the jacket, right, which is going to be 40% of 2,000. Now, if you do the math on this, you get 800. And there's a quick way and a long way of doing that, right? So the long way is to do the normal multiplication on your notes. But this is the kind of thing you can, with a bit of practice, also do in your head and very quickly. Why? Because effectively what we're doing here is we've got a 4 and we've got a 2, and those are the only digits we have, right? The rest is kind of like how many zeros we have and where the dot is. And I know that 4 times 2 is going to give us 8, right? And that's the 8 that's here. So the way I would do this personally is think, okay, 4 times 2 is 8, and then is it going to be 80? Is it going to be 800? Is it going to be 8,000? 8 million? Well, if we're taking a 3-piece suit at $2,000 and we're taking 40% of that, so we would not expect this price to be higher than 2,000, right? It doesn't make sense that the kit in itself costs 8 million or 8,000 or 800,000, etc., right? So anything above is going to be too big. Okay. Now, could it cost $8 or 80 cents? Probably not, right? Because that would be a huge price drop compared to the original price. And here we can use the fact that 40% is a bit less than half of the costs, the total cost. So what would be half of 2,000? It would be $1,000. So something a little bit less than 1,000 that starts with an 8, well, that's going to be the 800. So that's a really quick way of just doing that math without having to write it down your piece of paper and worrying about where you put the dots and the number of zeros, etc. So work out the 8 first and then sense check. Okay, is this going to be 800? Is it going to be 80? Is it going to be 8,000? That's the much more efficient way of doing things. So after that, what we're going to do is we're going to take this $800 jacket and we're going to mark it down twice. So a markdown of 30%. So here we're dealing with changes in percentages, right? So we're not going to take 30% of the 800, but what we're going to do is we're going to take that original price and remove 30% of it. Or another way of doing that is if you take 1 minus 0.3, so that's like kind of like 100% minus 30%, you're going to be left with 70% of the original price. And what we end up doing here is we're doing that twice. So one for the 30%, which is like multiplying by 70%. And then the second one is subtracting 40%, which is like taking 60% of the initial amount. So what we end up doing is we take the $800, and then we take 70% of that and then 60% of that. Now, how do we do that math efficiently? Well, there are different ways of doing it, but how I would do it personally, and how many of the high score testers would do this, is they would probably combine the 70 and 60% together first. Why would we do that? Well, because to calculate this, which is kind of like doing 70% of 60% or 60% of 70%, it's actually the same thing. In there, we've got a 7 and a 6, right? And we know from our times table that 7 times 6 is 42. Well, if you don't know that, you should probably remember it or learn it. And then it becomes just a question of zeros, or where we put the dot. So in this case, what we're doing is we're taking 70% of something, which is around 2/3 of something. Then we're taking another 60% of that, which is around 2/3 again. So if you take 2/3 of something and you take 2/3 of it again, roughly you're going to be halving it. So overall, you're taking 42% of that amount, right? And why 42%? Because I know there's going to be a 42 in here. Just a question of number of zeros, and something roughly half the value is going to be 0.42. It's not going to be 4.2, and it's not going to be 420. It's not going to be 0.042 because that would be too small. So again, here I'm working out the numbers first and then worrying about the number of zeros, or where to put the dot. So then when we're taking 42% of 800, well, here we can use another trick, which is to say, hang on, I've got 2 zeros here, and I've got 0.42 here. So I can kind of say this is like 8 times 100, and use that 100 to turn this 0.42 into a 42. Right, so I'm effectively just moving the 100 over here. And then we've got an 8 times 42, which is nice and neat. There's no dots in there. Now we just need to finish off the calculation by doing that. The easiest way to do it is to split the 42 and say we do 8 times 40 and then 8 times 2. 8 times 40 is like doing 8 times 4 and adding a 0. So that's 32 and a 0 in the end. That's 320. And then 8 times 2 is 16. Okay, add them together, we get 336. Now, notice that all these calculations, I've managed to whittle them down to just doing a times table calculation, right? So there was 4 times 2, there was 7 times 6, and then there was 8 times 4 and 8 times 2. Right? I'm really keeping things super simple. And then I'm using the fact that I can tell, okay, how many zeros, where's the dot going to be, just by sense checking things. It's a really powerful way of doing this. Right, now, there are obviously other ways of doing this question and going quicker than that, right? Because we can rule out quite a few answers just by sense checking. Now, what do I mean by that? Well, if we're starting with 2000 and we're taking 40% of that, so we're taking roughly half, right? That's going to be 1,000, okay? And then we're marking that down by 30%, so we're taking 30% off, right? That will give us 700 or a bit less, right? And then we're marking that down by 40%, so it's going to be a bit more than half of that, right? So we're going to be around 350 something, okay? And just by doing that in my head, I can tell it's not going to be 32 because that's going to be way too cheap. It's not going to be 3,850 because that wouldn't really make sense anyway, right? It's more than the initial price. So it's probably going to be between B, C, and D. And if I just look a little bit closer at the numbers, I can reassure myself that, yeah, it's probably going to be the middle one, 336. Okay? So that's another way of doing this, where we're using this sense checking technique, which is really powerful in the GMAT, to eliminate some answers and then see maybe where we should look more closely at the numbers to do the calculation a little bit thoroughly. But again, maybe here it would depend on like how much time we've got, right? If this is the last question and I've only got like 20 seconds to do it, I would probably just rule out A and E quite quickly, the way I did it, and then I would make a guess on the last three. And based on that very quick sense checking I did, I'm probably going to go for the middle one.